Hi everyone, welcome to class today and we'll be learning absolute values in algebra.
So what is an absolute value? The absolute value of a number is the number's distance from zero. This means that it will always be positive because the distance is positive. So an absolute value of a number is written inside two bars called the absolute value bars. For example, the absolute value of x would be written as this. So the two bars would be around the x. So here's a visual representation. So here's how to visualize absolute value on the number line. Remember, the absolute value is a number's distance from zero. So the absolute value of -4 would be 4 because as you can see on the number line, -4 is 4 away from zero. So here's a trick for finding any absolute value. So the absolute value of any number is just a positive version of that number. For example, a positive number's absolute value would just be the number itself. For example, the absolute value of 5 is 5. A negative number's absolute value is the same number but without the negative sign. For example, the absolute value of -5 is 5.
Let's think about it like this. 9 is always going to be 9 away from 0, and -9 is always 9 away from 0. So the absolute value of 9 is 9, and the absolute value of -9 is also 9. So operations inside an absolute value. So how do operations work inside an absolute value? Basically, it works exactly the same, but after you have to make sure that your answer is positive. So let's take the example 2 times -3 plus 5. We would do PEMDAS, so you multiply 2 times -3 to get -6, and then you would add 5 to get -1, and because it's an absolute value sign, you would have to make a positive, so your answer will be 1. Let's go ahead and do some examples. Let's try 2 times -8 plus 5. 2 times -8 is -16. Add 5 to get -11. And with the absolute value sign, you get 11. For our second problem, multiply 2 and 3 to get 6. Then add 5 to get 11. And the distance from 0 is 11.
So now we're going to talk about absolute value equations. Absolute value equations are pretty much the same. In this case, the solution could be a positive or a negative since it is inside the absolute value bars. For example, in the absolute value of u equals a, u could be either equal to a or negative a. And we would write this as plus minus like that, and it means plus or minus. So in this case, u would equal plus or minus a. So here's an example. We have 5x minus 3 equals the absolute value of 4. So the absolute value of 4 could mean either positive 4 or negative 4. So the two possibilities for the equations are 5x minus 3 equals 4 or 5x minus 3 equals -4. So we would solve both of them. So we would get 5x equals 7 or 5x equals -1, which means x is either 7/5 or -1/5.
So now we're gonna see how we graph an absolute value graph. So the expression, as mentioned above, the expression in the absolute value bars will always be positive. So that means the y value of an absolute value graph will always be positive, will always be greater than or equal to 0. And if the whole function is in the absolute value bars, then the whole function will be above the x-axis. So once again, absolute value just measures the magnitude, the distance from 0. So that distance will always, it will always have a positive value. So if we look at the graph, y equals absolute value of x, it'll have a V shape. So now we're gonna try and guess which one it is because there are many graphs here. And as mentioned above, we can rule out A because A has negative y value. See, this line is just y equals x. See how to the left of 0, the graph has negative y value. So we can rule A out, and using that same logic, we can rule C out. C is wrong. And then again, D has negative y values as well. See how it goes to -2 and -4. So we can rule D out. And therefore, by process of elimination, we can see that number B, letter B, is the absolute value graph, is a graph y equals absolute value of x. See, as I mentioned earlier, it has a V shape. So basically, if we look at A, this is y equals x. So if we bring all the values to the left of the 0 in graph A and reflect it across the x-axis, then we'll get graph B. So basically, again, absolute value graphs do not have negative y values.
All right, that's it for the lesson today. So thank you everyone for listening.